Here's another video about solving a system of nonlinear equations. The top equation is the equation of an ellipse of some kind. Here's an ellipse. Pretend like that's an ellipse. And this is a linear equation, a line. So here's the possibilities. An ellipse could be intersected with a line at two places. The line could be tangent, where it only intersects one place, or they could completely miss each other, and there would be zero solutions in this case, one in this case, two in that case. So we don't know what's going to happen, so we're going to see what happens here. Let's see. This is not a system that I would try to solve by elimination methods. This is a system I would use substitution, and the reason is I do not have like terms. See, x squared plus x cannot be combined, and y squared plus y or plus negative y cannot be combined. So you could solve it by elimination, but that's going to get a little bit messy. What I would rather do is solve by a substitution. So I'm going to choose to solve for one variable, get it by itself. So I'm going to look at the second equation. I'm going to get x by itself. X is equal to, I'm going to add y to both sides and get y minus 2. All right, then I'm going to look at the first equation. And instead of putting in x for x squared, I'm going to put in this, I'm going to substitute in y minus 2 for x, it's going to get squared, plus 2y is equal to 2y squared is equal to 5. So that's just by substitution. Then I'm going to use order of operations to try to simplify this. So y minus 2 squared is equal to y squared minus 4y plus 4 plus 2y squared is equal to 5. I'm going to distribute the 3y squared minus 12y plus 12 plus 2y squared is equal to 5. I'm going to combine like terms. 5y squared minus 12y plus 12 is 5. I see that I do not have a linear equation, but I've got a quadratic equation I need to solve. So I need to solve it by a quadratic method. You could solve this system by possibly factoring, possibly taking the square root if it happens that way. It doesn't look like it's going to happen that way. So if you wanted to take the square root, you could complete the square and then take the square root, or by quadratic formula. I'm going to solve this by factoring because I think I remember this one factors. I'm going to give it a shot anyway. So I need a 0 on the right hand side before I try to factor this. So I get 5y squared minus 12y plus 7 is 0. So right here, I'm going to use the AC method. A is 5, B is negative 12, C is 7. A times C, 5 times 7 is 35. I need two things that I can multiply to get 35, but add to get negative 12. Negative 5 times the negative 7 will give me positive 35, and they will add up to be negative 12. So these are good choices. Rewrite the middle term, 5y squared minus 5y minus 7y plus 7 is equal to 0. So all I did was rewrite this middle term into these two factors. Once I see four terms, I just group the first two and the second two and factor out the greatest common factor from each grouping. I can pull out 5 times y, leaving me with y minus 1. I can pull out a negative 7, leaving me with y minus 1. These match, not coincidentally, but because I chose the right numbers. I'll finish my factorization up here. Y minus 1 times 5y minus 7 is 0. Set each factor equal to 0 and solve. So when I set y minus 1 equal to 0, I get y is 1. When I set 5y minus 7 equal to 0 and solve, I get y is 7 over 5. Now, what was I doing in the first place? I was solving this system of equation. So when my y-coordinate is 1, what would the x-coordinate be that goes with that? Well, I need to plug it into an equation somewhere and solve. I'm going to select this one right here. That looks the easiest way to go. X is equal to 1 minus 2. X is equal to negative 1. So that tells me that when x is negative 1, y is 1. This is one point of intersection. Let me plug this value, y is 7/5, again into this equation. X is equal to 7 over 5 minus 2. X is 7 over 5 minus 10 over 5. If I get a common denominator of 5, And then I get x is negative 3 over 5. When x is negative 3/5, y is 7/5. So I get 2 points of intersection. So it's some ellipse that's being intersected by the line at 2 places. And this is the solution to this system.